Imagine typing in a search box and watching results appear instantly. No lag, no wasted time, just smooth, real-time feedback. But behind the scenes, without smart optimization, every keystroke can trigger dozens of unnecessary computations or network requests, bogging down your app and overwhelming your backend. If you want to build lightning-fast search features that scale, you need more than just clever UI. You need to master debouncing in JavaScript. In this tutorial, you'll discover how to build a powerful custom debounce utility from scratch, tailored for pure front-end apps. You'll learn not just what debouncing is, but how it actually works at the function level, why it's different from throttling, and how to integrate it seamlessly with real-time search for a truly responsive user experience. By the end, you'll be able to cut down wasted resources, improve your app's performance, and deliver professional-grade search interfaces that feel instant to your users. Whether you're working with large datasets or connecting to APIs, this skill will help you create scalable, maintainable, and user-friendly features that stand out. If you're committed to leveling up your JavaScript expertise and want early access to more in-depth real-world tutorials like this, make sure you subscribe and enable notifications. That way, you'll always stay ahead with the latest tools and techniques in modern web development. Imagine the modern web application as a bustling city intersection at rush hour, with cars representing user events, each keystroke, click, or scroll. If every car, event, tried to pass through immediately, chaos would ensue, traffic jams, honking, and delays. Debouncing in JavaScript acts like a smart traffic light, spacing out the flow so only the necessary cars proceed after a brief pause. The fundamental concept of debouncing centers on controlling how often a function actually executes in response to a burst of rapid-fire events. By introducing a short waiting period, debouncing ensures that the function, such as a search query handler, only runs after activity subsides, optimizing both performance and resource usage. In practical terms, this means that as a user types Apple into a search bar, instead of firing off 5 network requests, one per letter, debouncing groups the keystrokes and triggers just a single search after the user pauses. This not only reduces server load, but also enhances the user's perception of responsiveness, as the interface feels less jittery and more thoughtfully paced. Debouncing, therefore, is not just a technical trick, it's an essential pattern for making front-end applications both efficient and delightful to use, particularly when dealing with real-time interactions and costly operations like API calls. To fully grasp the utility of debouncing, consider the anatomy of event handling in JavaScript. Browsers emit events, such as input, resize, or scroll, at a remarkable pace, often dozens of times per second. If every event triggers an immediate, potentially expensive computation, the result is a sluggish interface, network saturation, and a poor user experience. Debouncing introduces a buffer, or gatekeeper, between the event source and the handler function. Each time an event occurs, the buffer resets a timer. Only if the timer completes without interruption does the handler execute. This mechanism is akin to waiting for the ripples in a pond to settle before tossing another stone, ensuring that each action gets the attention it deserves without being lost in a storm of activity. In the context of real-time search, this approach is transformative. A debounced handler waits until the user stops typing for a set period, say 300 milliseconds, before invoking the search logic. This not only minimizes unnecessary work, but also aligns system feedback with user intent, delivering results at the pace of natural interaction. By integrating debouncing into event-driven code, developers create interfaces that scale gracefully, remain snappy under stress, and avoid the pitfalls of overreactive design. This is the core custom debounce utility implemented in modern JavaScript. It supports both leading and trailing edge execution, preserves context, allows cancellation, and is designed for easy integration with real-time search in front-end apps. This file demonstrates integrating the custom debounce utility into a real-time search input. It simulates async search, provides immediate UI feedback, and ensures only the latest input triggers the search logic. This HTML file sets up the basic UI for the real-time search demo. It includes an input field, a results container, minimal styling, and loads the search logic as an ES module. This just test file provides automated unit tests for the custom debounce utility, verifying timing, leading trailing execution, and cancellation. This is the project's configuration file, specifying dependencies, scripts, and metadata for development and testing. The application loads and displays a real-time search interface with a search input field labeled Search. The interface is ready for interaction with a list of possible results below the search bar. The user focuses on the search input field and slowly types the letter A. A brief pause follows, allowing the debounce timer to process the input. After a moment, the search triggers, and the results update to display all items containing the letter A. The interface might briefly show a loading indicator such as searching before the results appear. Next, the user types the letter P after another deliberate pause. Once again, the debounce mechanism waits for a short period of inactivity before executing the search. The results refresh to reflect items containing AP, such as apple and papaya. The user observes that the search only triggers after they finish typing, not on every keystroke, demonstrating the debounce effect. The user then rapidly types the letters P, L, and E in quick succession, completing the word apple. Because the input events occur in rapid sequence, the debounce utility resets the timer with each keystroke, and the search executes only after typing ceases. Once the debounce delay elapses, the search runs a single time, updating the results to show apple. The user scrolls down the page to view additional features, such as a visual debounce timeline and inspector, which may illustrate the timing and execution of debounced events. There is a brief pause to observe these elements. Returning to the search input, the user clears the field, waits for a moment, and then quickly types berry. After typing stops, and once the debounce timer completes, the search function executes, and the results update to highlight all items containing berry, such as strawberry and blueberry. The user scrolls back up to the top of the interface, returning focus to the main search features. To demonstrate the application's empty state, the user clears the input field, waits, and then types a nonsensical string like XYZ fairly quickly. After the debounce delay, the search executes and, finding no matching results, displays a message such as "No results found" in the results area. With the demonstration complete, the interface remains responsive, and all elements are in their final state. You've just unlocked one of the most powerful patterns for building smooth, efficient, and user-friendly web interfaces: custom debouncing in JavaScript. By mastering this utility, you can instantly optimize real-time search, prevent wasted API calls, and deliver a seamless experience your users will notice and love. This skill isn't just for search bars. Debouncing is the secret weapon behind responsive forms, intelligent validation, and lightning-fast UI interactions in every modern web app. Take what you've learned today and start applying it to your own projects. You'll see fewer bottlenecks, clearer code, and happier users. If you want to keep leveling up with practical real-world techniques like this, explained clearly and ready to use, subscribe now. You'll accelerate your learning curve and stay at the forefront of front-end development, equipped to tackle any challenge that comes your way.